Okay, we continue on to question number 5. Calculate the concentration of H plus in a solution that has a pH of 8.38. So, you know that pH is equivalent to negative log H plus. Therefore, your H plus is equivalent to 10 minus. So, from the question, the pH is actually 8.38. So, 8.38. So, you should get the concentration of H plus is equivalent to 4.1687 times 10 to the power of negative 9. Question number 6. The pH of a 0.150 molar solution of an aqueous weak monoprotic acid is 4.10. Determine the Ka for the acid. So, you know that they ask you to find the Ka, means that this is a weak acid. So, given to you, the concentration of the acid is equivalent to 0.150 molar. And the pH is equivalent to 4.10. So what is the Ka? Okay. So because you know the pH, you can find the concentration of H plus. Since it's stated in the question that it is a monoprotic acid, so it means that the amount of H plus is just 1. So therefore, from your pH equivalent to 4.10, you can actually find the concentration of H plus. Therefore, concentration of H plus is equivalent to 10 to the power of negative 4.10. Therefore, you will get 7.9433 times 10 to the power of negative 5. So this is your H plus. And then you know that the initial concentration of this acid is 0.150. The next thing you need to do is do an ice diagram. So from the ice diagram, we know that it's a monoprotic acid, so HA, so it will dissociate to H plus A, supposedly this one will be A minus. So when you do the ice diagram, you will get like initial concentration 0.150. So initially there's no dissociation occurs, so 0, 0. Therefore, in change, you have negative x, and x. So at equilibrium, you will have this. So from the calculation before, we already calculate the value of x, which is the concentration of H plus. This one, concentration of H plus from the pH given in the question. Therefore, you know the value of x. So 7.9433 times 10 to the power of negative 5, which is the value of x. You just plug it in your equation for Ka. So supposedly when you do the calculation, you will get 6.3096 times 10 to the power of negative 9 divided by 0.1499. Supposedly, if I calculate it correctly, you should get 4.2092 times 10 to the power of negative 8. So this is your final answer. Moving on to question number 7. 10 mole of helium gas was filled into a balloon that can inflate to hold 5,000 liters. Currently, the balloon is not fully inflated to the high pressure on the ground. Determine the pressure when the balloon rises to a point where the temperature is 10 degrees Celsius and the balloon has completely filled with the gas. So, this is obviously a gas law question. So, given to you in the question is the number of mole, N equivalent to 10 moles. And then here stated that the volume, if it inflates fully, it should fill 5,000 liters, and then the temperature is at 10 degrees Celsius. Right. So from here, you know that you have N. So the rule of thumb is that if you have N here, definitely you need to use the ideal gas law. So we use PV equivalent to nRT. So your pressure is the thing that you want to find. Determine the pressure when the balloon rises to a point where temperature is 10 degrees Celsius. So your pressure is the one that you want to calculate, and then it states here when it inflates fully, the balloon will go up till 5,000 liters. So V must be in liters, so no need to convert. So your N should be 10 moles, which is in the question already. R is a constant value, which is 0.0821, and your temperature here given in the question, the temperature is 10 degrees Celsius, so this one should be converted to Kelvin. So when you calculate, you need to convert it. So 10 plus 273. So your P is this one divided by 5,000. You should get 0.04646 atm. So yep. Question number 8. Hydrogen sulfate react with sulfur dioxide to give water and sulfur. If 6 liters of H2S gas at 750 torr produce 3.2 grams of sulfur, calculate temperature in degrees Celsius. Right. So again, this is a question for the gas law. So this kind of question, they actually help you to create your chemical equation, but you should at least know the chemical formula for each and every thing that is being reacted. So given here, H2S reacts with sulfur, definitely sulfur dioxide, definitely you know sulfur dioxide as O2, to give out water and also sulfur. So when you get an equation like this, you need to make sure that this equation is being balanced. So at first you need to look at the number of sulfur here. One here, there's only one here. But if you look closely, you need to check on the hydrogen as well. So hydrogen is H2 here and H2 here. No problem. At the moment, there's no problem with hydrogen, but some problem occurs in the oxygen. So here you have 2 oxygen, now only have 1. The only thing you can do is that you need to put 2 around here. So you have 2 oxygen now, and here 2 times 2, you have 4. So you need to put 2 around here, because 2 times 2 for the hydrogen will be 4. Now supposedly 2 times 1 equals to 2 plus another 1 sulfur here. So you have 3 sulfur altogether. So around here you need to put 3. So this equation is balanced now. Okay, looking back at the question given to you that the gas is at 750 torr. So this is not in the unit that we want. In gas law, especially in the ideal gas law, you need to always change the unit for your pressure into atm. So when you want to convert it to atm, so 750 divided by 760 equivalent to 0.9868 atm. This is after conversion. Right. So now, what else is given in the question? The amount of sulfur being produced is 3.2 gram. So mass of sulfur is equivalent to 3.2 gram. Therefore, from the mass, what we can actually get is the number of mole. So the number of mole is equivalent to mass over RMM. So the mass is 3.2. The RMM for sulfur is 32.06. So from the calculation, you should get 0.0998 mole of sulfur. So the question said that 6 liters of H2S gas at 750 torr produce 3.2 gram of sulfur. So calculate the temperature in degrees Celsius. So what we have calculated now is the number of mole of sulfur. So in saying that, from the calculation, if we were to talk about H2S, we will have the pressure equivalent to 0.9868 atm. Volume is in the question, which is 6.0 liter, and then the temperature stated in the question is the one that you want to calculate, so you need to know the N, because you are going to use the ideal gas law, PV equivalent to nRT. So your T is the thing that you want to calculate. So how can you get the N? So from this calculation, we know that the number of mole for sulfur, N for sulfur, is equivalent to 0.0998 mole. So by using the chemical equation that we have done, 3 mole of sulfur will be produced if you have 2 mole of H2S. So now, since we have 0.0998 mole of sulfur, we could easily calculate the number of mole for H2S, which is 2 divided by 3 times 0.0998, which you will get around 0.0667 mole of H2S. Okay. Therefore, you can plug in all this value in the ideal gas law equation. So PV equivalent to nRT. Your pressure is equivalent to 0.9868. Volume is 6 liter. N is this one. So 0.0667. R is a constant value, 0.0821. And your T is the one that you want to calculate. So your T is equivalent to 1081.2133 Kelvin. So remember, the unit for ideal gas law supposedly is in Kelvin, but the question asks you to calculate the temperature in degrees Celsius. So you need to convert it to degrees Celsius. So 1081.2133 minus 273, you should get 808 degrees Celsius.